Okay, we're going to take a look at central angles and arc measurements. Now, an arc is just part of a circle consisting of 2 points. Okay. Semicircles are, it's just part of it. Half of a circle, just part of it. We need to know what that angle measure is to identify what the arc is going to be. It'll be kind of coming up. So, these are things that you should probably make sure that you have down. Here, fix this a little bit. So I'll give you a few moments to make sure that you get the stuff down, and just make sure that you identify what's in blue. You don't have to write everything down. Just identify what a minor arc is, what the measure of the minor arc is. Major arc, measure of major arc, semicircle. Get that information. All right. Now, minor and major. Minor is lesser, major is more, right? Makes sense. And a semi is always going to be half of it. Just things to keep in mind. So, if I want to identify a central angle, minor arc, major arc, and a semicircle, what would that look like? Well, first offhand, do I have a circle? Do I have anything that looks like an arc? I get bits and pieces of things, right? So, if I want to go and take care of some central arcs, okay? Now, what does it mean by a central arc again? Okay, let's go back to it here. Minor arc. An angle whose vertex is at the center of a circle is called a central angle. Okay? The diagram shows, so that means that that's a central angle. So, if I want identify a central angle, how many central angles do you actually see? Now, this is kind of going to mess with you a little bit, because if we think about a straight line or a straight angle, that's an angle, right? 180 degrees. Yes? No? Because we've talked about zero angles. We've talked about acute angles. We've talked about right angles. We've talked about obtuse angles. And we've talked about a straight angle. When we are dealing with this, all we want to deal with are acute, right, and obtuse. Those are the only kind of angles we really want to concern ourselves with. So, knowing that much, if I wanted a central angle, would one of the angles be angle CPA? Does that work? Would that be a central angle? Okay. Center right there. Would I also have angle BPA? Would that work? And those would be the only angles that we would be looking at. So, that takes care of the central angles. What happens if I want a minor arc? What would be a minor arc? Well, okay. A minor arc is an arc that is smaller than half a circle. So that means I could have arc AC. Now, mind you, it's going to have that written over the top. Arc what? EC? No. There's no line. D is just happens to be a pointer. Okay. And another one would end up being, well, if AC is one, what would be another one? AB. And again, it's got to have that one. So, what about major arcs? Now it says a major arc is an arc that is larger than half the circle. So if I wanted to try and identify a major arc, well, what about arc that goes from A, D, C? Okay, this is why D actually counts, and I'll explain why. There are two possible ways of getting from here to there. One of the possible ways is to start at A and go this way around, correct? Is it also possible to go from A over to C? Okay. So if I put that point of D in there, am I telling myself which way I'm going? I want to go from A to C through what point? D. If I'm talking about a minor arc, I would want to go just from A to C. Now, it is possible that you could even list it. Say I had a point that was like this. Say I had a point here that was called E. I could even call this arc here A, E, C. That could be an arc as well, okay? All we're doing is just identifying which way is it going. So is there another major arc that I could come up with? Sure, I could also do arc B, D, C. I got it from B. Oh, you're right. I'd have to go to what? If I got to have a major arc, it's bigger than a semicircle, so I'd have to go from B, D to A. Now, could I call this arc? Yes. Like I can't. Okay. The reason why I didn't say A, B, D, C is because I really only need one of those to identify. Okay. When I get down here and I wrote this one in down here and I said A, B, C, all it's telling us is that I want to go from A to C this way. Why? Because I got to go from A through point B in one case, or I've got to go through point D in another case. Okay. Just like when we have lines and we can name them different things, but they'd be the exact same line, I can name an arc two different ways for it to be the exact same arc. The key point that you got to pay attention to is whatever the point is here and the point is over here, where it starts and where it goes to. Okay? Starts at A, goes to C. Which way does it go? Has to go through B. Or it goes from A, goes to C, but it has to go through what point? D. So I know that it's going this way. Does that make sense? So, what would happen if I want to identify a semicircle? Well, if I wanted to identify the semicircles that are in here, I have a semicircle that goes from B, D, C. Is that one semicircle? That goes from here up to there. And then what I still got to go from B to C, correct? But if I want to go the other way, what would I say it's going through? Which point? A. So yes. That middle point just identifies which one it goes through to get there. So, let's try this. What is the measure of arc AB? What's the arc measure? 35 degrees. How do I know that? Because it tells me that this angle here is 35 degrees, so if that angle is 35 degrees, that arc measure is 35 degrees. That's just the way it is. Congruent arcs. Now, if I say the measure of DE is given by that expression, the measure of HJ is given by that expression, and I have this, all that means is that 3x plus 10 is equal to 5x minus 40. And you know how to go through and solve that stuff, right? Subtract 3x, subtract 3x, add 40, add 40, and I end up with 50 is equal to 2x, divide by 2, divide by 2. 25 is equal to x. So I got the answer, right? Have I answered the question? One of the things that I want you guys to focus on is actually reading what the question is. I've noticed a lot of it that you just zip through it, you come up with something, put it down, but you don't complete the answer. So that means that I can put it in as 3 times 25 plus 10, 75 plus 10, well that means it's 85. Does this mean it's the same thing? What is 5 times 25 minus 40? Wasn't that 125 minus 40? So that would be 85, correct? So they actually are. But please make sure that you answer the question. Now, we've talked about segment addition. We have talked about angle addition. And if we can add segments together and get a longer segment, if we can add angles together and get a bigger angle, can we add arcs together and get a bigger arc? Most definitely. So, what this is telling us, it's saying the measure of angle of arc QR plus the measure of arc RS goes from Q to S. Well, that makes sense. If I've got this here from Q to R, and then I've got from R to S, and I put those together, that would just make one larger arc, correct? See, again, a lot of this stuff is, well, duh, of course it's going to be. Okay? But now these are the rules that say that it can't be done. So, with that information, use the arc addition postulate to write the expression. Now, most of you would just simply go through and say AC is equal to 115, right? But you didn't read. They want the expression. Well, I need to go from A to C all the way over here using angle addition. So that means I have to have the measure of what? AD could be. Okay. So, how do we know which way it's going to go? Generally speaking, your minor arcs will not go through and identify a third point. Major arcs will go through and identify a third point. Now, do I actually have any information about what AB is? I could figure it out if I wanted to, but I'm really not given any information that goes through and tells me exactly what that is. Okay? Now, if I wanted to go to AC, I'd have to go to AB and then to BC. That would give me ABC. But generally speaking, when it was been done, minor arcs are just going to start and finish. Major arcs are going to have that third in there. Okay. So this is going to be, what's the other one? BC. So that's the expression that represents the measure of arc AC. Now, if I went and told you that, oh no, you were wrong, it was supposed to be arc AB plus BC to get the correct answer, could you argue the point that this is correct? And the answer would be yes. Why? It says write an expression that represents the measure of arc AC. That's kind of where things start getting a little difficult to think about when we're dealing with circles, because there's always two ways to go, correct? So that's why my recommendation is that the way the rules are usually going to be, yes, I am usually using the word usually, not 100%, 99.9% of the time, when they have just an A to C minor arc. 99.9% of the time, well actually 100% of the time, if they put a third point in there, that's the way you gotta go. Usually. Yeah. That's kind of the problem that you are going to run across with math books and textbooks in general and definitions. Sometimes authors use different notations to represent the same stuff. Always comes like this, when in doubt, ask. So, I want to find the measure of angle AC. Now I take a look. AD is 80 plus DC is 35. So when I add those up, I get what? 115 degrees. That's what I know to be. So, that go right? Okay. So I'm going to give you about a minute or so here, and I want you to go and draw this self out for you. Identify the one. Okay. So what I want to do here now is I want to draw a diagram of a circle. Gee, if I'm going to draw the diagram of a circle, I'm just going to have something that's going to look like this, right? There's a diagram of a circle. Identifying a central angle. Central angle is going to have a center point, and I'm just going to call that the P. That works, right? So I need to have a minor arc and a major arc. So if I have a line that's going from here to here, and I call this point A. And if I go from here to here, and I call this point B, I would have, well, I would have arc AB, right? And I would have arc AB. That doesn't help me out one bit, does it? So if I want to go and set my major arc, I'm going to put a point over here, C, and then I am going to say that this one is arc ACB. Okay? So now I've got it going that, hey, when I go from A to B, I want to go this way around through to C, as opposed to going from here to here, which would just be. Make sense? So, give you another minute, and I'll let you figure this one. Ready? So, what is the measure of the minor arc? Right there? That doesn't help much. So, minor arc should be 115 degrees. Yep. I know it was a difficult one. So, give you a minute or so. So, what'd you end up with for X? So, X is equal to 45. Then, Logan, what'd you get for the measure of each arc? What'd you get for the measure of the arc? What did you get? What do you have written down? Nothing. Well, that's not cool. So, if they're telling me that JK is congruent to LM, that means that the measure of JK is the same as the measure of LM, right? Yes, no, maybe so? Probably. So that means that it's got to be 2x minus 15 is going to be equal to x plus 30. So if I subtract an x, I subtract an x, I add 15, I add 15, I end up with x is equal to 45. And so if I want to find out what that is, well, I could just put x plus 30, so that means it's going to be 45 plus 30, which is 75. If I go and take 2 times x minus 15, well, that means it would be 2 times 45 minus 15. 90 minus 15, I get 75 again. So it really doesn't matter which one you plug it back into, you just plug it back in and figure it out. Of course, it means you actually have to do that. So, I'm going to give you a minute or so here, and I want you to write an arc addition postulate to represent the measure of. All right. So, who can give me a possible arc addition postulate for the measure of arc AB? What could it be? You got an idea which two arcs you could multiply together or add together to get that? F. So you want measure of arc AF, you say? Plus what? Oh, you want it BF. Sorry. Oh, see, okay. I'm supposed to go from A over to B, right? I could go that way, or I can go this way. ABF? Well, yeah, but CBF? Okay, but where am I going to start and where am I going to end? If I want arc AB, I got to go from A to B. Those have to be my endpoints. So there's a possibility that I could write this as a measure of AF plus the measure of FB. Would that work? Would that give me what I want? Is that an arc addition postulate to get me to AB? Yes or no? Yes or no? Go from A to F. Could I do this? Does that work? Could I add the one that goes from A to D and then from B to B? Okay. Could I say that the measure of AB is equal to measure of AD plus measure of DC plus measure of what? What would be the last one? If I went from A to D, D to C, then I'd have to go from what to what? C to B. There you go.